See, MOS can be used as a resistor, MOS can be used as a capacitor also. So in some bipolar processes, MOS capacitor is special options. So especially you can fabricate this MOS exclusively for this application, so that you can use this MOS permanently as a capacitor. So the capacitance, whatever value you get is 1 to 5 femtofarad per micrometer square, and it is 20 to 100 times larger. So the value of capacitance obtained is 20 to 100 times larger. And very, very important thing is capacitors made out of MOS, they have a very low temperature dependence that is measured from the temperature coefficient. It is just 30 ppm per degree Celsius. But previously we have seen 1000, 5000. So the variation is very large. But see, it is just 30 ppm per degree Celsius. So I can say the temperature effect is very, very small. Or when the temperature is going to increase, the capacitance value will not increase so much. It is going to be increasing in a lesser way. And gate capacitance, sometimes if you want to circuits to have a larger value of DC also, that is possible by using a fabrication method. So you have to keep the transistor in strong inversion. So strong inversion means, VGS value should be more than VT. So whatever gate source voltage value we have, it should be more than threshold voltage VT. Otherwise, the capacitance will become lossy. Okay. So on occasionally an accumulation mode MOSFET construction using N plus source drain well can also solve this problem. So accumulation is going to be on, it is just like an enhancement mode MOSFET. So that can also be providing a capacitive effect at the gate junction. So by using a N plus source diffusion layer, I can use this MOSFET as a capacitor, and it is going to solve some problem. It is going to eliminate a few of the problems which is listed above. So this type of capacitor requires nothing above what is already available, but it uses the same procedure, but maybe you cannot have or you cannot flexibly control it using the fabrication methodology. Okay. So for see the symbolically it is given for both types of gate capacitors. The Q depends on channel resistance. So you have a channel between source and drain, and the channel current depends on what the resistance value RDS between source and drain. So you have a gate metal oxide semiconductor layer, and I am having splitting this as RDS by 2 on source side and RDS by 2 on drain side. So it is just like capacitance and two resistance in parallel. So I can simplify it into capacitance and RDS by 4. You see from this side, RDS by 2 between gate and this point, and RDS by 2 again between gate and this point. So RDS by 2 parallel to RDS by 2. You will have RDS by 4, and this gate capacitance is in series. So I can write the equivalent circuit like this. So RDS by 4 in series with the capacitor.